Welcome to the final session of the NBP Symposium for 2018, and we've got 4 short presentations from some very talented researchers, and these are people who are actually in the field trying to get research going where we link genetics and environment, and also trying to get data visualization. Jan Holtz will be presenting some of his reflections on getting data viz going for Oliger's project and reproducibility, and Andrea Garner we've really been inspired by Andrea's work, but he's got a much bolder vision he wants to share with us. Esben will talk a little bit about how he's explored this practically in Danish registers, and Andrew Schultz got some really brilliant ideas about future studies as well. But it's my great pleasure to introduce min kære ven Esben Agerbo, so Esben, as you know, he's a character. He's one of the we all love him dearly. He's a professor at Aarhus University, and he's a very high-profile researcher. He's a very busy guy, and like every week he's getting a new publication out. And like the last 3 weeks, NCRR has had a publication each week. And I think last week there's a paper that Esben was involved in looking at the links between mental illness and being a victim or a subject of a crime, attracted a lot of attention. And this week there's one coming out about mental health in women that have had abortions. So you can see that Esben and the other senior staff at NCRR are really involved in generating very important international research. But Esben, what I like about him is he thinks and worries a lot about combining genetic and environmental data, and I really enjoy my chats with Esben over the coffee machine or in his office. And if you visit his office, he's got all these wonderful little religious symbols, and he's got a Donald Trump noddy head. And I thought, what can I buy Esben that I wanted a gift to give him? So I found online on Etsy a flying spaghetti monster. So he now has that in his office. But Esben, please join us and tell us a little bit about some of your applications with gene environment analysis. Thanks very much.
Thank you, John. I mean, that's, thank you for the flying spaghetti monster. I really enjoyed that. So, before I start, maybe I should prime you a little bit, because my good colleague and good friend, Carsten, he usually nominates my talks. And the last one, he said, this is simply the worst talk you ever gave. And this time he also said, I mean, you definitely have the most boring title. And I think Carsten, he has a point. So the outline here is that I will say something about the polygenic risk score as a mediator. This is actually where I started working with polygenic risk scores, thinking about this as a mediator between parental background and outcomes. And then the next thing is the polygenic risk score as a confounder. And the next point is the polygenic risk score and progression of disease. And here, progression of disease, I think this is the kind of word that epidemiologists use for looking what happens after becoming a case, for instance, case-only studies. And I think that we will see a lot more of that. Polygenic risk score and secondary phenotype analysis. I think it's not that we have solved this. We have done some of these, and there's a very nice statistical literature on that. But so these are the 4 points that I will talk about. And what I will show is some of the studies that we already did publish, and some of the things that we have in the pipeline for publishing. So, I mean, genetics for dummies, you could say. The polygenic risk score as a mediator. So by this, I think we have I think of the polygenic risk score between parental background and disease outcome, and I like the polygenic risk score because I really believe that your genes are inherited from your parents. So that's a really good start. So we can order these things in time, and often it's difficult in epidemiology to do that. So my first attempt, and this is, I mean, a really clumsy study. You should never read it. But here, so this was just after the first schizophrenia paper, and in this I tried to I tried to combine the register data with genetic data to see how much of the parental background I could block by what I could observe in genes. And of course I knew that, and the reviewers, they were killing me and say, much too small a study, and they are of course right. I mean, this was a terrible small study, but we did it anyhow, and here I made also a really, really clumsy polygenic risk score. I mean, it's something that I just took some SNPs near exons of candidate genes, and then I made a kind of internal, something that you should never do. But I did it. So time passed, same data, but now the 2014 schizophrenia paper that Naomi talked about had been published, and now we had much better summary statistics, but still the same data. And I think one lesson here is, of course, that the power of these things are in the discovery. So very small, 900 cases and controls. So I just show a few slides from that paper, and I think a good thing about this, you might not believe it, and I did not make much of a fuss about this, but the good thing is that Liselotte has actually replicated this in a bigger sample. So we see that the polygenic risk score for schizophrenia is associated with the odds of schizophrenia, really nice, and this is for those without a family history of any psychiatric disorder. So now we took, I took those with bipolar affective disorder, and what you see is that here for those with low genetic liability, they are kind of shifted up. So there's some, I mean, of course, something not captured by the polygenic risk score, but after this, these are basically parallel, log parallel. And now what about the family history of psychosis? So you see, if you have a low genetic liability, then there's very little effect of family history. I mean, this is normally maybe a 4 or something like this, but then the increase is steeper. So this is one way to think about interaction. So maybe this polygenic risk score is actually getting the right SNPs for those with a family history. I don't know. So another thing we did in this paper was that we calculated how much of the family history for schizophrenia and psychosis were mediated through what we could see in this polygenic risk score. And here it was 17%. And if I took the interaction that I just talked about into account, then this polygenic risk score nearly captured half. So the two first studies, they are basically the same, but with much better data. It's the same hypothesis. And because I'm so simple-minded, I thought we should, I skipped this a little. I thought we should do, so you see, I mean, exactly the same title, but now a different outcome. So, yeah, it's the salami method that we use. So this is a paper that we are about to write up. So Søren Dinesen Østergaard is writing it up. Bettina did the analysis, and I can't remember what I did. But look here, this beautiful figure that Bettina made. So here you have cases with ADHD, and you have some without ADHD. And then she simply just draw the distribution of the polygenic risk score. And I think this is really nice. This is something that, I mean, geneticists, they probably look a lot at figures like this, but what may kind of, I mean, for me it was a little surprising. I mean, for the first time, how such a small difference, you see just this small shift to the right for those with higher genetic loading of ADHD, how that could transfer into this odds ratio difference. So here we had the polygenic risk score. Bettina chopped it into 50 pieces, and then just regressed them again ADHD. And you see, it's really a nice. It's really a nice dose-response relationship. So. It should resemble the other paper. So Bettina made some LS means. You could think of them of adjusted means, and then she looked at these are mothers. Mothers do not have any psychiatric disorder. Mother have one in the psychotic spectrum, or in affective and anxiety, or else. And the red dots are the average polygenic risk score for those with ADHD, and they are all about the blue ones. So that is, I mean, that's of course this you would expect, but maybe you would also expect some kind of pattern in this. But then another figure that I think is also quite interesting. So here it's the mother's education, and here we have primary education only, high school, short, medium, PhD or longer. And this is not an interaction. No, this is not an interaction. But then again, I don't know if there's some kind of decline here. Would it be that mothers with higher education tend to have kids with lower genetic loading for ADHD? Yeah, maybe. So okay, while we were at it. So now, one more time, the same study. This is an analysis that Thomas is doing right now, and we are not really sure how to figure this out. It's an idea from Diana. So here we have the polygenic risk score in deciles for those for autism spectrum disorder, and here we have those with outer family history. And here we see this expected dose-response relationship, but you don't see that among those with a family history. It's a little tricky to compare these curves, because of course the blue curve is should be shifted up, because they of course have much higher risk of autism in the first place. So it's something we're working on. We are not really comfortable with where we are, but it's Thomas, you made these last week, so I think we'll figure it out. Okay, as a confounder, again, very simple. We have an outcome, we have some risk factor of interest. One of the good old candidates that we're interested in, that we know from the literature. Then we ask, so this polygenic risk score, can it explain away it is, or how much of this is actually through this risk factor? And the first study we did was with Michael Benros, wrote the paper, and with this we looked at an old hobby horse in schizophrenia research, infections. So if you suffer from an infection, then the risk of schizophrenia is much higher, and we can of course think about, who gets these fungal, virus and bacteria infections that we pick up from the registers. So we tried to see, can we take this away? How is there some kind of interaction with the polygenic risk score for schizophrenia? And this is a figure from the paper. You see blue, no infection, red infection, and the polygenic risk score in quartiles. So you see this kind of upwards trend. Yeah. And you see maybe there's so you can see that they are actually both the red and the blue are having an infection is a risk factor, and genetic loading is as well. So a little surprising that they actually took the paper, because there's nothing really significant in this. But while we were at it, we thought we might as well just make another one. If they would take the first, why shouldn't they take the second? Yeah, and so they did. And this is a paper by Holger. It's Liselotte who did the analysis of this one. And here the factor that we're interested in is school grades. We know that if you do poorly, you have bad grades when you finish primary school, then your risk of schizophrenia is higher. And then we did basically the same exercise as before. So Liselotte made this curve. We have an average here of the polygenic risk scores, and red is schizophrenia cases, and blue are non-cases. And what you see here for these guys here are those who did not finish school. These are those who had the lowest grades and then so on. These are those with the highest grades. So you can see that the genetic loading of schizophrenia is pretty high, no matter which grade you actually had. Maybe, I don't know, it's much to say that it's higher among those who don't finish school. I don't know, it would fit well with what we think of this. So, and here the second thing, this is the polygenetic risk score that Peter just talked about, the one for educational attainment. It's not the newest one because we'll see a little bit of the newest one later, but this one was accepted with an old one. But this is a really, really surprisingly well-working polygenetic risk score. I'm really, really surprised by how good it is, and I'll show you something more about that later. So what you see is a very nice dose response with the polygenetic risk score, of educational attainment. So, I mean, higher genetic loading for educational attainment with higher grades. And even also for those who do not finish school. So wonderful, wonderful. But then again, I mean, not really anything interesting in the sense of interactions or stuff like that. Okay, now we did more or less the same exercise. An old darling in schizophrenia is being born in an urban area. I mean, we know people who are born in an urban area tend to have higher risk of schizophrenia. And then Diana Paxarian wrote this paper where we looked at basically the same. I should also say that Bettina did these very nice analysis here, and we had good advice also from a number of people, including John. Thank you, John. So here here, which you cannot see, here we have the capital, and then we have decreasing degree of urbanicity. Here we have rural areas. Thank you, Nana. And I don't know. So these are measured at two different time points, at birth and at 15 years where you live at. And I don't know, is there something going on here? I don't know. We were very worried, and what we're worried about is collider bias in this sense. So I think Naomi already talked a little bit about collider biases. So that's why we publish combined results. They also the other ones you can see in the supplement if you ever look this paper up. So this led us to together with Jakob and Thomas and Joseph Smith and Esther to think about. Now we don't call it collider bias, but we call it collider effects. I mean, recognizing, you of course know that. I'll get back to that. But here are some of the results of Esther's analysis. So here we have polygenetic risk score for ADHD and for ADHD and for autism and depression. And here we have birth weight, and then they are regressed against each other. So of course you will worry about a collider effect when you condition on like case-only studies for these. I mean, for genetics and birth weight having negative, if they're independent, having negative correlations. So this leads me to progression of disease, because I think a main thing to think about in progression of disease studies, and this. I'm sure we have already seen a lot of these studies, but we will see a lot more because we will look at people will look at cases and look in the future for personalized medicine or stuff like that. But what you have to think about it is collider bias. I think that's one of the things. So if you have two risk factors into the phenotype of your condition, and they will have, if they're independent and they're both risk factors, you will always have a negative correlation. But this is what I learned during this. There's also something called supra-additive effects, and I had a little help from Jakob to show that if you have two independent risk factors and you condition on disease, but they only have an interaction effect. I mean, something you would always teach statistics students not to look at, but with epistatics effect, we might think of that. You will always have a positive collider effect. I think that is pretty pretty strange. Okay. So this is a story where Teresa looked at treatment-resistant schizophrenia and regressed that against the Polden risk score for schizophrenia, and there's little association here with the risk of becoming treatment-resistant. So the same small data as the very first I showed you. Maybe if you have some previous comorbidities in terms of other psychiatric stuff going on, maybe you're more likely to become treatment resistant. Okay. And maybe, I don't know if this could be a collider effect. So another thing, study from, how am I doing time-wise? Good. I'm good. So this is a study by Søren, and Søren, I mean, it's such a long title that I think I have to read it. So, polygenic risk score, parental socioeconomic status, family history of psychiatric and substance use disorders, conduct disorders, and the risk of substance use disorders in ADHD. So that means that Søren told me I'm a clinician and I really need to know my patients. I mean, all these guys with ADHD, they tend to get substance use disorders, and I want to know a little bit more about this. I mean, paraphrasing Søren a little bit, and then we said, I mean, these are some of the candidates for this. So we conditioned on ADHD, and then we asked here for the Polden risk score. In deciles for the Polden risk score for ADHD, and ask how does it associate with substance use disorders among females and males. And I don't know, is there something going on here? I'm not really sure. But Søren had a good reason for doing this, because he has previously published findings that might suggest that women who are diagnosed with ADHD actually have higher genetic liability for ADHD. So, so you see the Polden risk score, average boys, girls. If you're young, they're very likely to become young when diagnosed. You're likely to become a misuser. If you have conduct disorders and so on. Never mind. I'll drop this. So the last thing that I would like to talk about is secondary phenotype analysis, and that is because, you know, genetic data are actually collected most often by conditioning on being a case or control. So it's not really random in that sense. That is how the data are gathered. That somebody are sick and somebody are healthy. But often with these data, you would like to study something else than what they were collected for. And I think there's a nice statistical literature, you know, inverse probability weighting and all this kind of thing. But we're also a little cautious with using it, but I think we should think about that. So this box here means that we condition on selection into case controls, and then we do like this. So the first study that I would like to show is now, this, Peter, is with the new summary statistics for educational attainment. So it's with some econometricians, and they tend to order people after alphabetically. So that's why it's me first here. So here we see the distribution among males and females for the Polden risk score for educational attainment. Nice, really nice. And remember the figure that Beard made for ADHD when I show you the next one. I mean, remember how these small differences can change the odds. So this is, now we simply condition on family, low socioeconomic status and high socioeconomic status. So look at the shift here. I mean, that's quite amazing. So the genetic loading is much higher if you are from a family with high SES, socioeconomic status. Maybe not surprising, given what Peter showed us earlier. So, but this study, I like it somehow because it's riding one of my many hobby horses, and one of them is that here we condition on high socioeconomic background in parents. So these girls and boys are well off, from a well off family. And what we see here, that the polygen risk score for educational attainment and years of schooling, and we see this kind of dose-response relationship. Maybe girls, we know that girls start off much better than boys. They are. I mean, of course, we know that for a long time. But you see that boys need to be genetically well endowed for having an effect of their score, even in these families. Maybe so much for girls. But what about the other one? What about low socioeconomic status from parents? You see this increase. So girls from a poor background do well, and girls from a good background do well. But boys, we need both. Yeah. So a little discrimination here. Yeah. I don't know if that's because of the why. Yeah. So. I think the last study I'll do is also an old study by Thomas. Bettina did the analysis, and here it's old data. It's secondary phenotype because look at the polygen risk score if you suffer from schizophrenia and family history, and here we actually, the good thing about this data, they're actually conditioned here. Cases and controls are born on the same day with the same sex. So that's the virtue of this design. You see that the total effect of the polygen risk score is from the polygen risk score on death, and it's this effect plus this effect. So that's 1.15. And family history, I mean, everything is family history, of course. So you see so I should hurry up now, shouldn't I? Yeah, okay. So I'll skip the rest of these. They're not that interesting. The last thing that I would like to, I mean, you can read the paper. Well written, Thomas. Yeah. So this is the last thing. This is something that is, I mean, we have thought a lot about this, and we don't really know what to do. We look at whether you vote or not. So we have 3 elections: European Parliament, the Parliament election, and municipality election. And we know that here, healthy, this is how people vote. If they're healthy, do they vote yes or no? And of course, we know that it's not surprising that girls with anorexia are very likely to vote. I mean, it's kind of, I mean, what would you expect? And Søren said, you would always expect that guys with schizophrenia, and especially ADHD, which of course he's a child psychiatrist, and know that boys with ADHD are much too, I mean, unorganized to vote. So what if we look on heritabilities in this? We cannot really figure out how to estimate the heritability from this heritability of voting. It's wonderful phenotype, but then again, how do we do this? So this was my last slide, and I would like to say thank you very much to everybody who did the work while I was, I mean, enjoying myself. There's a picture.
There's the monster.
Yeah, here you have the spaghetti monster. So starting and beginning with spaghetti monster.
Thank you.
Yeah. Yeah.
I can't see Donald Trump naughty head in that figure, but Esben, that was great. Is Carsten in the audience? That you wouldn't give him, like, that's not the worst talk he's given, or that was a good talk. Questions for Esben? Naomi?
I've got lots of questions actually, but so the mortality study, the mortality risk ratio, which data set was that? That's not iPsych, no?
No, that is the kind of pilot for iPsych. So we did a nested case control study and it's also in iPsych now, the data. So it's schizophrenia cases and then matched controls, but they are matched at the time in the future when the case becomes a case. So that's very beautiful thing about that data set.
So the age of those people is still relatively young then?
Yes,
so
and that's also, that's why you see such a big effect. I mean, maybe you remember the effect from yesterday. That's why you see a 9 here. Isn't that so, Thomas? Thomas is nodding, yeah.
So does that mean it's capturing like suicide or something like that? Or?
There are too few suicides in this for looking at.
And my other question was about the analysis with schizophrenia and birth weight. And you said a collider effect. Can you just explain that again?
Yeah. It's We didn't call it collider bias because there's actually no bias. Maybe so. The trouble with collider is that you would expect a negative association, but in these maybe there's no association, or maybe it's for both cases and controls that tend to be a kind of decreasing birth weight with the polygenic risk score. It didn't seem to differ that much between cases and controls, and I know that Esther, she will try to replicate this in the UK Biobank data. Isn't it so, Jakob?
What are you thinking, Naomi? What's your concern?
We did analyses looking at, so in one of John's studies, he'd looked at age at first birth. And of course, age at first birth is going to be related to birth weight. And John, in epidemiological data, Danish data, you'd found that U-shaped distribution.
Yes.
And when we did polygenic risk score into age at first birth, we also got that U-shaped distribution. So, I don't know what they're saying, but
in GSMR, we could do MT-COJO analysis. So you can maybe adjust for a polygene score for low birth weight to see where the polygene score for schizophrenia still predicts the outcome.
But I think also it's maybe an attempt to think about collider bias. As the paper you showed, this kaleidoscope paper, and the reason one by the same group where they look that attrition in Alzheimer's is actually associated with a whole range of polygenic risk scores. So I think this paper is kind of an attempt to do that, but then again, we don't call it collider bias because we actually don't think that it's a bias. To some extent, we hope that it actually will give a little more credence to birth weight being a risk factor in some of these. I understand your question because maybe it's a little misleading to think about this as a collider.
Okay, we might wind up there. Esben, thank you very much for the presentation.